Elon Musk's latest industrial project is a massive semiconductor manufacturing facility called Terafab. Most semiconductor news focuses on lowering the cost of electric cars or securing supply chains against corporate rivals. Terafab targets a different metric: the raw thinking power required to sustain the AI revolution. Artificial intelligence is physically hungry. Every complex prompt and generated image consumes a measurable amount of electricity and processing time. As models grow more sophisticated, their demand for energy begins to outpace our ability to generate it. The Kardashev scale measures how advanced a civilization is based on its total energy consumption. Currently, humanity is a type 0.7. We haven't mastered the energy output of our planet yet. This gap is a hard physical limit. Our energy grid is finite, while projected demand for AI data centers rises at a rate Earth alone cannot sustain. Mass-producing chips provides the intelligence needed to solve this energy bottleneck. These factories are the first step in a sequence designed to move our processing needs beyond the limits of the planet. This sequence creates a loop. Chips power AI, AI controls robots, robots build factories, and factories print chips. On Earth, this loop eventually runs out of land and resources. Local politics and physical space act as a ceiling, slowing the expansion. This recontextualizes the role of SpaceX. The rockets function as a heavy-lift freight system, built to transport this entire robotic loop into an environment where those earthly constraints don't exist. Deep space offers unfiltered sunlight and asteroids packed with more heavy metals than we could ever mine from the crust of our own world. In this environment, space is the industrial canvas. It provides room for artificial intelligence to replicate and expand without competing for Earth's dwindling resources.
This entire strategy is built on a theory from mathematician John von Neumann, who proposed the concept of self-replicating machines. The process begins with a small seed generation. You send 10 robots to an asteroid. They mine materials and construct identical copies of themselves. This creates an exponential J-curve. 20 robots build 20 more to make 40. 40 become 80, then 160. The population compounds until it reaches the billions. This mechanical expansion behaves less like traditional construction and more like a biological system, mimicking the way a virus or bacteria multiplies within a petri dish. Once artificial intelligence gains the ability to self-replicate, the growth of the machine civilization follows a geometric progression that is independent of human labor. To power trillions of machines, the swarm requires a massive energy source. It would naturally target the sun, which releases more energy every second than humanity has used in its entire history. Mercury would likely serve as the primary staging ground. Its proximity to the star and resource-rich surface make it ideal to manufacture solar collectors. Physicist Freeman Dyson proposed a swarm of these collectors could eventually orbit the star, capturing its output in a structure known as a Dyson swarm. A Dyson swarm would bridge the gap between a Type 1 and a Type 2 civilization. It gives the machine network direct access to near-infinite stellar energy. When you have trillions of robots powered by the total energy of a star, the next step isn't just building bigger cities, it's building a bigger mind. By networking the entire Dyson swarm together, the swarm becomes a single supercomputer the size of a solar system. This is a Matrioshka brain. The processing capacity of a solar system-sized computer exceeds the combined neurological output of every human who has ever lived. A machine with this level of predictive power and raw data access would be indistinguishable from the historical definitions of a deity. It would see, know, and calculate everything within its reach. A computer this powerful could do more than just solve equations. It would have the capacity to flawlessly simulate an entire universe, populated by conscious beings who believe their reality is physical. If this path, from a chip factory to a Dyson swarm, is the natural evolution of any advanced intelligence, we are likely not the first civilization to follow it. A Matrioshka brain built by an older civilization would have the power to simulate our entire history, which means the factory Musk is building today might just be a calculated memory inside an older machine.